Caveman Math back with another video. I know it has been almost 2 months since I've covered anything on the channel. This is going to be a comprehensive review of the first unit of Precalculus, right? Now, this is our Unit 1 review packet, which is going to go over the Unit 1 tests. So if anyone finds this helpful, please tell me in the comments. All right, first concept we're going to go over is what implicit and explicit functions are, right? And why we need to even find these things, right? Basically, the definition of an implicit function is when it's defined by an equation not solved for the dependent variable, which is called an implicit function, right? So basically, an explicit function is if y has been expressed in the terms of x alone, then it is called an explicit function, right? So now we need to know, why do we even need to find these, right? The reason we need to find explicit and implicit functions is because they're useful when describing different kinds of relationships between variables. Basically, they just explain things in terms of y, which is very helpful when you're trying to graph. So let's start out with the first one, right? The first one, first we need to write it in terms of y, right? So y equals, right, plus or minus root of x minus 25, okay? And well, now that it is in terms of y, because you know when we brought x to the other side, it just turned into so it just turned into x and then minus, and then we had to root it because y squared. Well, if you want to get rid of the square root of y, you need to give this a root. Now that we have done that, we have to plug in each individual one of these. So this one, and this one. So f of negative 2, x minus h, and f of 5. The way we do this is, well, if you plug it in, you'll go like, okay, negative 2, we'll just do like negative 2 negative y squared equals 25. If we do this, it's just be negative 2, and sorry, negative, and then you bring this to the other side, so it's just 25 plus 27, oh, not 27, sorry, plus 2, right? And that becomes 27. So when that becomes 27, if you are going to divide by negative, give this a negative, right? And then try to root it, so you'll go like y squared equals, y equals root of 27 negative. That's undefined. You cannot do that, right? So the conclusion we come to is that f of negative 2 is undefined, right? And we go to the next one, which is f of x minus h equals plus or minus root of this. Okay, so basically what we do here is we plug in x minus h, we plug it into x, so that'll just give us this essentially. It'll give us the plus or minus, right, root of x minus h minus 25. Now, why is this? It's because when you plug this into this, right, when it comes to the other side, well, okay, it came to the other side. Okay, what do we do now? We try to free the y, right? When we try to free the y, it gives this a root, right? And this is just this. It's just this. So this is right. It's not undefined. Now we try it with 5, right? We have to do this for each individual function, right? For each individual function that's stated up here. Now we plug in f of 5. When you plug in f of 5, you'll get this. You'll get 5 negative y squared equals 25, right? And when you do that, well, you bring 5 to the other side, and that's 20, right? Negative y squared equals 20. Now, you can't really do anything with this, so it's really undefined. So y equals, that's just root of 20. You can't do anything with root of 20. That is undefined. All right. Root of negative 20. My bad. All right. Next one. What we're going to do. Oh my God. Man, he's calling me in front of the lesson. Broda, I must call him back. I must call him back later. Hello, broddas. I am back. I had to take this call with my friend, man. Oh my God, he calling in the middle of the video. This is for you, Abdul, brother. You are going to be immortalized in this video. But let's get straight to it. Now, when we plug in negative 2 into x, we basically get this, right? We have 2y, and then we have minus 4, and then we have, you know, the negative 2, right? And then that's to the power of 2 plus 8 equals 0. Oh, and never mind, we don't need equal to 0 again. But it's like, sorry, equal to 0, right? Essentially, what this is right now we just solve this and we have to put this equal to y, right? So we have to make 2 equal to all of that, right? So when we do this, it's just 4, right? And then 4, you know, plus this negative 4 is just 0. So that just goes out, right? So we are left with 2y equals to negative 8, right? And when we subtract this, wait, what? We don't even need to do this. What the hell? What am I doing? Wait, what am I doing? What? That's crazy. Okay, no. I went wrong here. I'm gonna come back to this. Yeah, no, it seems that this is right. This is the right way to solve it. So this just becomes 0. So what happens is 2y is equal to negative 8, and then this just goes out, I guess. I'm kind of looking at a key right now, and it's also wrong because I want to make sure that I'm teaching this to you guys accurately. That's awkward. Okay, so essentially this is just negative 4, right? And well, this is what this is. So it's f of negative 2 equals to negative 4, right? And what else? What else might you say? Okay, we have to go after this one, the x minus h, right? And when you go after x minus h, right, x minus h equals, so you just plug this in, right? You plug it into this. So when you do that, when you plug it into x, you get this. You get 2x squared minus 4x h plus 2h squared minus 4. I encourage all of you to practice this and resolve it because it's really important. Now, if we do the same thing for 5, right? You plug in 5 to x here, you go like this, right? You go f of 5, right? And then you put it equal to 2y minus 5 to the power of 2 plus 8. Essentially, you just do this. So what's 5 to the power of 2? 25. 25 times negative 4. Wow, I'm very caveman math. I need to do this. I'll be right back. All right, I am back, my friends. It is just 100. So we have 2y, and then we have, you know, you got the negative 100 plus 8, right? And negative 100 plus 8, just 92. So 22y, right? Negative 92. Okay, and well, what do we do now? Like, what on earth is this? Okay, we're going to do 2y is equal to 92. Let's get all of this clutter out of the way. Get this up here. Okay, 2y 92, right? And when you do this, it's just divided by 2, divided by 2. And well, 92 divided by 2 is just 46. So y equals 46. And when that equals 46, you just write it as this, you know, as the final answer, which is f of 5 equals 46, right? And if you do this, the same thing with this, it's just going to go the same way. You plug in each of these values and you're going to get a set of answers that you have to write down, right? So just keep plugging it in to x and then finding it and setting it equal to y, right? Same thing goes for all of them. -9, and then you have f of x minus h equals to negative x squared. Oh, this is a long boy. We have to put this a little backwards. I'm gonna put a divider here because this is a bit long. Negative h squared plus 2h x plus 2x minus 2h minus 1. Now that is f of x of minus h, and f of 5 is equal to negative 19. Okay, now we are moving to domain of the following functions. This is very, very important because this is where most people kind of just blank out. So with square roots, you always have to set up an inequality. Now, what does that mean? It basically means put that number or that term or those terms or whatever, and just put them unequal to like this, 0. So not unequal, but greater or equal to 0. And then what you do is you just solve it as an inequality. So you do this, and then this goes to the other side, which is 1, right? And essentially what this tells you is that all numbers greater or equal to 1. So from 1 to infinity. So now you know that 1 is included and it goes to infinity, and that is your domain. With that, you know your domain. And for this one, it is different, however, because when it's 1 over 2x minus 1, essentially what you're doing is you're putting 2x minus 1 equal to 0. And what that does is, well, it tells you 2x equals 1, and that's just, you know, 1 over 2. So what you do with 1 over 2 is that you know that negative infinity to 1 over 2, right? And then, or, which is these, I think that's or. Well, 1 over 2, 0. Sorry, not 0, but infinity. All right, same thing for this one. You're going to do 25 unequal to 0. Oh, sorry, not sorry, my bad. 25 minus x equal to 0, right? And what you do here is you bring 25 to the other side, so negative x greater or equal to negative 25. Now, when you divide by a negative number, so in our case, it's just negative 1, and when you do this, it flips this sign. So this sign gets flipped, right? So now you have x is less than or equal to 25. And what that tells you is that it's all numbers, right? 25 equal to, so 25 equal to, and then less. So what that tells you is that negative infinity, so all numbers less than 25 to 25. And 25 is included, so you put a bracket instead of a parentheses. All right, next one, you kind of know the drill. It's the same thing. You put 1 minus 2x, and then you put equal, and then you put 0, and then you bring it to the other side. So negative 2x, you bring this over here, negative 1, 2, 2, And what this tells you is that, well, this is -2. So this is also -2. So what you get here is -infinity to 1/2. That is also your domain. All right, well, let's go on to the next one. This thing, you need to factor this first. I mean, do you? Can you? Yeah, you can. Yeah, so x, yeah, this is literally like a complete the square thing, this thing. So this is just x -2. That's it. And x -2. So you just have one number you're dealing with. So -infinity to 2 and 2 to infinity. All right, let's go for this one. Now this is a cubic function. Now cubics are just -infinity to infinity. They always go like this because, well, as you can see, they're always like this. Yeah. Well, okay, now this is a very important concept. I know people take this pretty lightly. Why do we even need to figure out if something is odd or even, right? Knowing this is an important property of a function that can help us understand or know the behavior of the function's graph. The reason we need to figure this out is because it tells us how to draw the graph before we even draw it or before we even find the points for it, right? So to save our time in graphing functions, we apply the properties of odd and even functions instead to predict the nature of the two functions, product and sum. So let's go ahead. Here, just to find this, we just substitute as -x. So you plug in -x to this stuff, to x. So to the function. So -x squared minus 9. Okay. What we do here is we look at it. Okay, what am I looking at here? What is x to the power of 2? X to the power, -x to the power of 2 is just x. So x squared, just x. So it's just positive. So we go back to the same thing. It's literally this, it did not change. So it is even. Even when signs don't change, right? That's what that basically means, right? It means that it's just positive. It looks like it's just even. It looks like it's positive, you know, like it is. That's how you tell it. That's how you tell how the graph looks like. So here, right, we determine this by also plugging in -x. So f of -x, we plug it into the x. -x squared minus 6 -x plus 9, right? And when you look at this, well, you go, okay, you already know that this becomes positive, and then this becomes, well, positive. So 6x plus 9. What happened to this is basically that one of the signs changed. So when one sign changes, neither. This is a neither function, right? And odd. Okay, odd is basically both of the signs have changed, right? So when we go f of -x, we plug in -x. Well, -x to the cube is just, you know, negative. So -x3 again. And then this is plus 4x because negative and negative equal positive. So when both sign change, odd. All right, let's go to the next one. Now, I'm not that well versed in piecewise functions, therefore I could not give you a good background on them as I'm still learning them. I'm going to come back to these in another video. Please stay posted. All right, going back to odd, even, and neither functions, this is one of the questions on that homework. So we need to look at this, right? Essentially, we have even functions, which are just normal, like this is a normal parabola facing up, positive. And we have an odd function, right? And then we have a neither function, which has no symmetry. And we have a function that is not a function. So it's not a function. Does not pass the vertical line test. So if you draw a vertical line, right? Like, let me demonstrate. If you draw a vertical line here, it passes through 2 points, right? Here. So you can't have a function existing at those points. Now, here are very important concepts that all of us should know for this exam and for Unit 1 of Precalculus. Linear functions look like this, right? This is kind of just basic review. Linear functions, they go straight like this, and the parent point or the parent function is f of x equals x. Their parent points are -1, 0, 0, and 1 and 1. Their domain is -infinity to +infinity. Constant functions, they are that number because they're a specific number on the graph. Their parent points are -1 to that number, 0 to that number, and x to that number. And domains are -infinity to +infinity. Absolute value functions are a V-shape, and their parent function is f of x equals to absolute value of x. And whatever is a product of absolute value is positive, always. So their parent points are -1, 2, 1, and then 0, 0, 1, and 1. And their domain is -infinity, +infinity. Rational functions are 1 over x, right? And their parent points are -1, -1, 1, 1, and their asymptotes are x equals 0, y equals 0. Domain is -infinity, +. Quadratics are a U shape, right? And they're -1 and 1, 0, 0, 1, 1, -infinity to +infinity. Cubic functions have a parent function of x to the power of 3, and their parent points are -1, 0, 0, 1, and 1. Their domain is -infinity to +infinity. They have this little kink shape that goes whoop up. And square root functions have a parent function of f of x equals a root of x. Their parent points are 0, 0, 1, and 1, 4, and 2. Because they go this way. Like normally, this is the positive, the even version. So it goes to the right. The domain is including 0 to infinity. So from 0 to infinity. And cube root functions are, oh, this is the wrong one, oopsie. So cube root of x. And their parent points are -1, -1, 0, 0, 1, 1. And they go like zoop horizontally. Exponential functions, right? They have asymptotes. So here, coincidentally, there is an I don't think I graphed this right. Yeah, the exponential functions have asymptotes. So x asymptote 0, y asymptote 0. They have asymptotes that guide where they should fall along. And if you have graphed your function to the point where it's surpassing those asymptotes, you have graphed it wrong. Logarithm functions are the same. They go along asymptotes, and if they follow those asymptotes, then they are correct. That is pretty much it for that portion. Let's go back to the review. All right, let's come back to transformations and critical points. Now, with the knowledge that we have just gained regarding the parent points and the default shapes of these transformations, we will start by identifying the parts of these transformations. First, we need to identify our A, which is, in this case, our A is 2. So we write down 2, which is this. Now our B is here, right? So our B in this case is, well, I would say that it is -1. Yeah, -1. So our H is still 2 here, and our K is 1 out here. So with this, we need to also write our parent points so we know how the default graph looks like. 0, 0, right? And the proper way to solve this is actually to write a table for it and plug in table of values and do all of that. Well, I'm not well versed in that method, so I would rather use the transformation formula, which is as follows. Okay, plugging in the parent points to x and y give us the advantage. So let us start by setting up our formula, which is this plus, well, 2 and then 2, right, y, and then plus a, which is our 1. Okay, plugging in 0, 0, we know that, well, okay, 0, 2, right, 0, and then we have 1. That is our first point. We cross this off. Now we do this with 1, we do negative, and then it's negative, -1, and then we have a negative, actually no, not negative, it is 1, and then we have a 1 plugged in here, which is 3 plus 4. Sorry, not 3. Wait, what did I do that? 3. It's just 3. Now we do this one. Or this one? This one. So 4 and 2. 4 here, plug in negative, so it is -2. And then our next one, 2, which is 4. 4 plus 1, 5. Alright, let's see if we have graphed this correctly. Alright, we're going to start by identifying these points on this graph. So 2 and 1 goes as follows. 2 and 1, okay, we have our first point. 1 and 3, this, right? What is our next one, you say? Well, we have -2 and 5. So we have our -2 here, and this is our 5. 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5. Yes, that is correct. This is a square root. Oh, crooked. This is our square root. Wait, I need to draw a straight line. Do this, please. Okay, there we go. That is our, square root. So the next one we'll go on to is this. We identify our A, which is 3, and then we identify our B, which is 1, because there is nothing in front of that X. And then we identify our H, which is 2, and then we identify our K, which is -4, right? We identify our parent points for this specific function, right? And as I said before, to identify these parent points, you have to kind of memorize what they are. But, essentially you get a hang of it, and, by the time that you memorize all of them, you already know them. So for example, we have -1, and then we have -1, and then we have 0, and then we have 0, and then we have negative, and then we have 1 and 1, right? So we start by plugging in to our values. We put this plus H and 3, and then Y, and then you got your K. You start negative, and that's 1, and then you go this, and then it's -3, so -3, 4, 5, 6, 7, 7. 7, negative 7. Oh, that's a crooked 7, right? And next one, 0, 0, well, you know, 0, and then it's 2, and then you have 0 here, which is negative 4. Ooh, okay. Now you plug in the ones. So when you plug in the ones, it's 3 and 3, which is negative 1. Okay, let us start by putting these points down on the graph. Okay, when we start doing this, well, it might be wrong, it might be right, but let's check. So 1 and negative 7. 1, 1, 2, 3, 4, 5. Wow, okay, 6, 7. That's a long way down. 7. Okay, 2 and negative 4. Okay, let's do this. So 1, 2. Oh wait, what? Okay, why did I do that? 1, 2. 1, 2, 3, 4. Okay, that is our 4. And our 3. 3. 1, 2, 3. 3, negative 1. Okay. This is going to look like this. Oh wait, that is a bit crooked. Alright, if you plug this into any math tool like Desmos or anything like that, then you will know that this is the correct shape. Alright, let's go for the next ones. Okay, this one seems to be a little bit more, you know, easier to solve because, well, it's verifying that they are inverses. Inverses are very important. Okay, and essentially what you do with these is you plug each equation into each other to find that if they are inverses or not. So for example, we have f of g of x, which is just, you know, where is it? We have our root 3, and then we have, okay, sorry, I kind of blanked out. Oh wait, that is in the wrong spot. Okay, f of g of x equals to 3 root, and then we have x plus 7 to the power of 3 inside of it, and then outside is negative 7. Now these cube roots cancel, which leaves us with this. X plus 7 minus 7, which is x. Now it's g of f of x, which leaves us with this. It leaves us with root, cube root, x minus 7 plus 7 to the power of 3. Okay, this cube root cancels. Well, that only cancels for the x though. What I can verify is that these become the same thing because they're both 7, so 49s, I mean not 49, sorry. They became the same number after being to the power of 3, so it still gives us x, right? Because we were freed from the x, and since these are both the same number, we know that when they subtract out, they eventually equal to x. Well, like they become 0, and then all we are left with is x. My bad. So now we need to find inverse of this. Okay, we are now met with something that is catastrophically hard to do for anyone who does not know how to do inverses. And my first step to inverses is putting them equal to x and swapping their values. So when you swap their values, right, you put 2y, and then you put negative 2. Oop, that is a weird y. 5y minus 4. Okay, now what you do here is you basically interchange the variables, you swap the sides, and when you swap the sides, when you multiply to two sides, you are left with this, right? You are left with 2 y, because you put 1 down here and then you multiply like this. You cross multiply, and when you do that, you are left with this. You are left with 5y minus 4, and then you have to multiply x, right? Because x is multiplied to this. And when you get that, you basically have this, right? You have 2y minus 2 equals 5xy minus 4x. And when you have that, well, you need to get rid of that x. So you could isolate y. Your goal is to isolate y, right? And when you isolate y, well, you have to get rid of the x's, put them to the side, put them somewhere where the light does not shine. That is 4x. Okay. Let's analyze the function one more time. We need to do this. Okay. Okay. So our next step is putting this down. 2y minus 5xy equals negative 4x plus 2. Okay, now we come over here and we factor out the x, right? So now we're left with, actually we factor out the y because we can factor out y. So we factor out the y, and now it is equal to negative 4x plus 2. Okay, now we divide. Oh my god, how revolutionary. When you divide this by 2 negative 5x to negative 5x, okay, we got this on lock. So now all you have to do is wait, let's backtrack a little bit. Oh wait, actually no, this is right. So y equals negative 4x plus 2 to negative, oh that's a z, that is not right, to negative 5x. Now you write it as an f of negative 1x and then equal to the same number, 2 minus 5x. This is the most comprehensive review of this unit that has ever probably been done on YouTube, because this video is going to be 40 minutes long. All right. Now, understanding this table, all right, there is a lot of fear regarding this table in my class because a lot of people don't understand it very well, but all you have to do is be able to read it. So to read this table, it says f of 2 plus g of 6. What f of 2 and g of 6? Okay, what is f of 2? F of 2 is 7. 7, okay, let's write that down. And we have g of 6. Okay, what's g of 6? We have 6 down here. G of 6, negative 3. Okay, so g of 6 is just negative 3. Okay, 7 minus 3, what is that? 4. Okay, we got it now. Now, what is the inverse of g of 4? Okay, we start from the inside. So we go, okay, what is g of 4? G of 4 is equal to, let's look at it, g of 4, 5. Okay, we know that it is 5. Now, what is the inverse of 5? What is the inverse of 5? What is that? What is the inverse of that? Sorry, inverse of g of, g of 4, 5. Okay. What is the inverse of that? And basically what that is you look down, you look, okay, 5, f of negative 1. 5 is negative 4. So it's just negative 4 because this is the inverse of f of negative 1. So that's just the inverse. And you look down and now you have this thing, right? So first we need to look at what this is. What is the inverse of 7? So f of inverse of 7. So inverse of 7 is 2, as I can see over there, 2 over, right, what is g of negative 8? G of negative 8 is 2. 2 over 2 is just 1. Well, that's the answer. Now we have to look at the inverse of g, so f of negative 4. So first we look at f of negative 4, which is evidently 3. So 3, right? And then, okay, what is the inverse? So g of inverse 3, right? What is the inverse of that? Big brain thinking. Wait up. Wait, I need to think about this. I will be right back. I actually messed up on this one. F of negative 4 is actually 5. So what is g of the inverse of 5? Well, that's just 4 because it's here, because you know it's the inverse of g of x. That is how you tell tables. One more time. So f of negative 4, we have spotted it here, right? And that is just 5, right? And inverse of 5g, so it's just g of inverse of 5, is 4. So that's how we found 4. I hope this was a very helpful guide, and I will catch you guys later. Caveman Math out.